Okay, we're going to do a quick lesson on powers of tens and scientific notation. Take a look at this table and you will see a pattern happening here. If I start with 10 to the third and I go to 10 to the second, I'm dividing by 10. Okay, 10 to the second to 10 to the first, again dividing by 10, dividing by 10, dividing by 10. Each time you divide by 10, the exponent decreases by 1. And the decimal point moves one place to the left. So it went from 1,000 to 100 to 10 to 1 to 0.1 to 0.01, 0.001. If you see the reverse of that down on the bottom, if I start down here at 10 to the negative third and multiply by 1, I get to 10 to the negative second, then 10 to the negative first. So each time I'm multiplying by 10, I'm adding 1 to the exponent and adding a 0. So the decimal point is moving to the right. Okay? Positive exponents mean larger numbers. It means that you move the decimal point to the right to make the number larger. And negative exponents mean smaller numbers, means you move the decimal point to the left to make smaller numbers. Now, how do we do that? You need to go back and remember that 10 to the 0 power is equal to 1. So that's basically where we're starting. We're starting with a 1. So when I'm asking you for the place value of 10, I start with 10 to the 0 power, which is 1. If I have a negative 6, that means I'm going to move this decimal point 6 places to the left. So 1, 2, 3, 4, 5, 6. Put in the zeros here, and you get 0.000001, 6 places behind the decimal point. Again, 10 to the 0 is 1, so I'm starting with 1, and this time I'm multiplying by 10, because 10 to the first is 10 times 1, which is 10. So I'm multiplying by 10 4 times, so that's going to be 10, 100, 1,000, 10,000. 1, 2, 3, 4. Fill in with the zeros. Okay? This one, again, I start with 1. I move it 9 places. 1, 2, 3, 4, 5, 6, 7, 8, 9. Fill in the zeros. And I have a 1 with 9 zeros behind it. Okay? All right. We need to be able to take large numbers or small numbers and write them as a power of 10. So that means I've got to take this and put the decimal point down here. So this is 10 to the what power? 10 to the what power? Well, 10 to the 0 power is 1. 10 to the first power, second, third, fourth, fifth, sixth. So that's 10 to the 6th power. Okay? Here, this would be, if it was 0.1, that would be 10 to the negative 1, negative 2, negative 3, negative 4, 10 to the negative 4. Okay, how many times did I have to divide by 10 for this to happen? Okay, if it started here, divided by 1, I get 1/10. 2, 3, 4. Okay, here, 10, again, 10 to the 0 power is 1, 10 to the first power, second power, third power. If you see a positive exponent, it means it belongs to a larger number. And if you see a negative exponent, it means it belongs to a negative number. Since these are all powers of 10, we use a base of 10 for each one of these. You can also do this for other numbers that are multiplied by a power of 10, but instead of starting with the 1 like we did, we start with the number that they give us. So if I start with 83.89 and multiply by 10 8 times, this is what happens when I multiply it by 1s, 2, 3, 4, 5, 6, 7, 8. Okay, fill in these zeros and get rid of the decimal point up here. Okay, and there's your number. If I'm dividing by 10, again, 4, 6, 7. If you do not see a decimal point, it's here at the end. So I'm going to divide by 10 3 times. So that's 1, 2, 3, and you get 0.467 for your answer. Okay, scientific notation is just a special usage of this. It's a way to write very large numbers or very small numbers. The first part is going to be a value that is equal to, greater than or equal to 1, but less than 10. In other words, you can only have one digit in front of the decimal point. Okay, so this is 3.5 times 10 to the 11th. 3.5 is not a very big number, but the 10 to the 11th is what gives it its value, because this number right here is actually 3 and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That is a whole lot bigger than 3.5, isn't it? So that's what gives it its value, whether it's a larger value or a smaller value. In this case, I start with 9.98, and every time I multiply by 10 to a negative exponent, remember it's dividing, so I'm going to do that twice, boom, boom, and that's going to give me 0.0998, which again is not the same as 9.98. 9.98 is almost 10, and that's definitely not almost 10. Okay? You need to pause the video and write these in scientific notation. Remember, it has to be the value in the front has to be a number that is greater than or equal to 1, but less than 10, and then times a power of 10. So this one's going to be 4.5 times 10 to the third. That decimal point's right here. It needs to move right here. Okay? This one's going to give me 2.0. I'll just put a 0 at the end. That means I moved it 1, 2, 3, 4, 5 places to the left, which is a negative move. Okay? This one's going to give me 6.56 times 10. And I know it's a positive exponent already because it's a larger number. 1, 2, 3, 4, 5, 6 times. And this one I know is going to be a negative number, negative exponent, because it's smaller. And I need to move it 1, 2, 3 places to go right there. So that's to the negative third power. Okay? I also need to be able to take it out of scientific notation and put it back in standard form, which basically means the way it's normally written. So I'm going to take 5.02 and multiply it by 10 3 times. Every time I multiply by 10, it moves the decimal point one place to the right. So this will be 5020. You should have paused the video and done this. This one's going to give me 5, 2, and ready. I move it once to get on the other side of the 8. That's 1, 2, 3, 4, 5, 6 times. Okay. Here, I start with the decimal point right here in front of the 0.3, and I move it 1, 2 places, fill in. Okay. Here, I start at the end. I move it 4 places to the left. So that's going to give me 0.0603. For this next one, I start right here. I move it 3 places to the left, which is going to give me 0.00541. And for the last one, I start right here and move it 6 places. So that's 1, 2, and then 4 more places that I need to fill in with zeros, and then fill in the values.